Good afternoon, and thank you so much for choosing the session Cloud Success Unlocked, Helvetia's Journey. Today's presentation is split in two parts, and you are watching right now at the agenda of the first part. This first part is delivered by AWS and myself, and the second part is delivered by Sasha from Helvetia. Our goal is to give you a behind-the-scenes look at what we have done and what we are doing at Helvetia. I will talk about what brought us on stage today, share some insights about the DC exit initiative we had completed together with Helvetia at the beginning of this year, and I will also share some insights and critical success factors that have contributed to the success of Helvetia's cloud journey. Finally, the topic that everyone talks about, generative AI, but here from a slightly different angle. We will shed some light on how you can make that technology available within your organization. But before we start, please allow me sometimes to introduce Sasha and myself. Sasha, the stage is yours.
Good evening. My name is Alexander, but since Ukrainian names are a little bit complicated, it's Sasha. Fun fact about me, I had colleagues who never knew that I'm actually Alexander, so that happened. I'm a software engineer by the background. Started quite a long time ago. In 2012, I believe I created my first AWS account. That's where DynamoDB was released. And since 2019, I'm working exclusively on cloud topics and currently cloud architecture lead at Helvetia.
Thank you so much, Sasha. Now to myself. My name is Jan Wild, and I'm a senior solutions architect at the financial services team at AWS in Switzerland, located here in Zurich. Fun fact, I am one of the few Amazonians that can fit its entire name into the 8 available characters of the email alias. So if you want to drop me a mail, use janwild@amazon.ch. I'm more than 6 years with AWS in Switzerland, and I mostly work with financial service customers. That's the reason why my area of depth is security and compliance. But as a former software developer and architect, I'm super passionate about serverless and enterprise integration patterns. But let's talk about Helvetia. The roots of Helvetia go back to the year 1858, where the Allgemeine Versicherungsgesellschaft Helvetia was founded in St. Gallen. That's, by the way, the year where the Eiger was first ascended and Rudolf Diesel and Max Planck were born. So a quite good year. Today, Helvetia is organized in a holding structure with more than 30,000 employees, 1/3 of them working in Switzerland. The company is organized in the 3 main segments: Switzerland, Europe, and specialty markets. The business volume in 2023 was over 11 billion Swiss francs. The protection forest campaign of Helvetia, making Switzerland a better place with planting trees where they can protect people, businesses, transportation routes, and hiking paths. And Sasha, right, you are running a cloud-first strategy.
Well, since we started about 7 years ago, and actually this year completed the DC exit, I would say cloud first and cloud only.
Awesome, and I assume AWS is one of your main cloud providers.
Definitely.
Okay, time is limited, especially in the last session where we stand between you and the drinks. So let's directly dive deep into how Helvetia's cloud strategy was executed in the last years. Again, we give you 2 unique perspectives. First, the solution architecture perspective, and later, the perspective from Sasha, who works for the cloud solutions team. 7 years ago, Helvetia started their cloud journey and created a small team that supported the organization in creating awesome products like a centralized and scalable container platform or a company-wide versatile integration layer that allowed the creation of modern applications directly on AWS. Thanks to a high degree of automation and self-service components, no prior cloud knowledge was required for the project teams to benefit immediately from these new technologies. The foundation for success was created, and the cloud solutions team earned trust across business and technical stakeholders. Fast forward, a few years later, the IT leadership team of Helvetia was faced with the decision to renew the on-prem data center contracts. What now? The IT leadership team of Helvetia decided to move all remaining applications to the cloud. And that was the moment when I realized as solution architect that there is a lot of work incoming to my desk. One of our goals was speed. So we decided to migrate 80% of the applications to the AWS cloud and move 20% of the applications to a managed services or specialty hosting, because these applications had a very strong requirement on a specific physical hardware, or were using an unsupported operating system like AS400. Thanks to the great expertise and support of IBM Nordcloud, which was the chosen migration partner of Helvetia, we were able to meet the deadline and literally pull the plug at the beginning of this year on the on-prem data centers. Important, these numbers do not reflect the entire application portfolio of Helvetia, but the scope of the DC exit initiative. Good. I would like to share with you some of the most critical success factors from an AWS solution architecture's perspective. And bear with us, 45 minutes are way too short to give you the full overview. So please do not hesitate to talk to us and ask follow-up questions during the apero. Sasha and myself are around and are happy to talk to you. Let's look at the first success factor, a scalable cloud foundation. It is literally the backbone of any successful cloud journey. Simply speaking, the cloud foundation consists of two parts, a technical part called landing zone and an organizational component often called cloud operating model that consists of business processes, people, and potentially the most important asset, skills. Combined, you will have your cloud foundation. But let's have a closer look at these two components. First, a landing zone is a concept or an architecture defining the way you use certain AWS services and third-party products to create the foundation. I often say a landing zone is the technical foundation to allow your organization to consume AWS services at scale and align to your corporate governance and any other type of internal and external regulations, giving you the control and oversight you would like to have when operating mission-critical applications on AWS, or drive innovation with modern technologies like generative AI. But I will come to that in a moment. When building your landing zone, you can start by your own or leverage AWS Control Tower to immediately start with a well-architected multi-account environment. But who is responsible for that landing zone? The CCOE, or Cloud Center of Excellence, is a team or group of individuals within an organization responsible for creating and implementing cloud-related best practices. A CCOE can help organizations effectively manage their business operations and deliver values to their customer. The CCOE team brings together representatives from otherwise siloed roles, like technical experts with the experience in cloud architecture, business analysts that help align the organizational overall objectives and bring business perspectives to the CCOE, or finance office professional that focuses on the cost implications of cloud adoption and make sure that your organization is making informed financial decisions related to cloud adoption. And many other roles, like innovation experts or legal and compliance professional, and super important, human resources professional, that can provide guidance on the skills and training needed to successfully adopt cloud technology and make sure that the organization's culture is aligned with cloud adoption. The Cloud Center of Excellence owns and drives innovation with the landing zone. At Helvetia, the CCOE is run by the Cloud Solutions team, and I'm glad to have Sasha from this team today with me on stage. Over time, the team created a comprehensive AWS landing zone, including an account vending machine that allows project teams to get a new AWS account with literally the push of a button. During the DC exit initiative, the team played a pivotal role in being the glue between the different stakeholders and AWS. And back to my role as an SA, I'm at least once a day in contact with someone from the Cloud Solutions team to discuss architectures and strategies to leverage AWS in the best possible and the most cost-effective way. I also have a Helvetia badge to meet the teams directly at their office location. So we have a solid foundation. What's next to ensure success while migrating workloads to AWS? Let's have a closer look at the second success factor, making data-driven decisions. Whether your organization has already decided to move to the cloud or is close to that decision, defining and documenting business drivers for cloud migration will clarify the reason for migrating and make sure you are not losing the focus. Business drivers should be linked to metrics that can be measured throughout the migration journey to validate whether outcomes have been achieved. Many customers are telling us that they are also looking to save costs when migrating to AWS, either to increase operational efficiency or to reinvest cost saving to drive new innovation. And so it was for Helvetia. The IT leadership was keen to have a strong platform to modernize, but also the business case had to make sense from a financial perspective and compared to the traditional hosting approach. So how could we make sure we get the clarity and data points required to calculate a business case, including a bill of material that is realistic? Migration Evaluator is a migration assessment service that helps you create a directional business case for your AWS migration. To project cloud cost, Migration Evaluator provides a clear baseline of what your organization is running today and projects AWS costs based on measured on-premise utilization and provisioning. Customers receive a breakdown of infrastructure and third-party software licensing costs, including options to right-size over-provisioned resources. And these data points can also be used to run further assessment to optimize database, storage, or licensing needs. So please do not fly without instruments when moving to the cloud. So we did the discovery, we created a solid business case, we also validated the capabilities of the landing zone, and now it's time to determine the best migration strategy. And this is a super individual process that depends on many factors. Maybe one of the most obvious one, do you still need this application? Or is this a third-party application, or are you owning the code base? Or is your application requiring any specific type of hardware or third-party database offering? Now, at Helvetia, we got an application portfolio consisting of hundreds of different applications. And we got a timeline that could not be extended. And you always must prepare yourself to discover alive dinosaurs or any special cases when emptying an entire physical data center. All roads lead to Rome, or in that case, to AWS. But the journey might be a different one. And I'm not going to dive deep in all of the possible migration strategy simply because we don't have enough time. Helvetia decided for low impact on business teams and speed. That's why the decision was made to move 80% of the application with the rehost or lift and shift strategy. Technically speaking, the migration from virtual machines and physical servers to EC2 instances on AWS, without touching or changing any of the components of the application itself. Obviously, when there were very, very low-hanging fruits, we did harvest them. So we use managed file system services or managed database offerings where appropriate and very easy to integrate. For the remaining 20% of the applications, we have chosen the retain or retire strategies because of strong dependencies on purpose-built hardware, unsupported operating systems, or simply because the application was not needed anymore. Rehost and then optimize is a powerful combo. And we see that typical customers already save money when rehosting applications to AWS. And additional optimizations can additional benefits along your migration journey. Organizations who migrated from on-prem to AWS can save on infrastructure costs of up to 66%. So we discussed the why, but I don't want to miss out on the how. Our companion for the lift and shift migration at Helvetia was the AWS Application Migration Service, which is a highly automated lift and shift or rehost solution that simplifies and reduces the cost of migrating applications to AWS. It allows companies to lift and shift a large number of servers without compatibility issues, performance disruptions, or long cut-over window. Under the hood, AWS Migration Service offers you mechanisms like an agent-based continuous block-level replication or an agentless replication for vCenter source environments. That means for you that your servers are being copied to AWS in the background while providing their normal offering, and you can decide the best moment for a cutover to AWS. And the best, it's easy to use and integrates well in your migration factory. But let me pause here for a moment. If there is only one thing you remember from this first part of the presentation, then it should be, don't just migrate to the cloud. Transform and optimize with AWS. Leverage our experience and proven solution to drive success at any stage of your cloud journey. When talking about modernizing applications or drive innovation in the cloud, organizations increasingly build on or with the support of foundational models and generative AI. Before I hand over to Sasha, I would like to share with you some insights how organizations can technically democratize the access to foundational model to make sure your teams can catch up with the increasing pace of innovation happening in this sector. It is safe to say that generative AI is here to stay. And I'm sure you heard that already at least once today. Amazon Bedrock is the easiest way on AWS to use foundational model from Amazon and third-party providers like Anthropic, AI21, and many more. Amazon Bedrock offers you a serverless API to directly interact with high-performing foundational models and allows you to customize these models or to enrich them with technologies like RAG, which allows the foundational model to gain very specific domain knowledge. The way you govern access to Amazon Bedrock and the underlying foundational models depends on your AWS landing zone as well as your governance and procurement processes. I would like to show you two different approaches that you can implement as part of your AWS landing zone. A strategy we see quite often, or with most of our customers, is the decentralized approach that leverages the guardrails and observability that is already built into your AWS landing zone. Projects team can directly interact with the Amazon Bedrock API to subscribe to foundational models or to use them. We also observe that customers are using with enterprise AI platforms that centrally govern the access to foundational models. In this architecture, projects team interact with your custom API, and this platform then leverage the Amazon Bedrock API or any other API. The benefits of creating such a platform is that you have even more control about the way you use foundational models, or you can implement functionalities that might not yet be available in Amazon Bedrock. If you are looking for guidance on how to start with such a centralized approach, please check out the AWS Solutions Library. You will find an architectural blueprint with sample code that you can directly use or improve according to your needs. To recap, a solid foundation ensures success with your cloud journey. Do your decisions based on data points. Select the right migration strategy and not just migrate, but also modernize with AWS. And finally, benefit from the capabilities of foundational model and generative AI and make this technology available to your teams. With that, I hand over to Sasha and say thank you. Sasha, the stage is yours.
Thank you, Jan. And believe it or not, because of the preparation to this talk, I was already talking with some of my colleagues about exactly one of those architectures, how to deploy GenAI.
That's fantastic.
really glad you're here because I joined Helvetia less than a year ago. So Jan is the eyewitness and person who was really participating. This is the first-hand account of amazing, fascinating cloud journey so far. Thank you so much.
Thank you, Sasha.
Well, welcome to the last 20 minutes. Thank you for staying. I really appreciate. What a day. What a day. When we're talking about cloud success, I think it's in a way a paradox. Everybody talks about cloud success, but not many people, not everyone really knows what it exactly is. So, yeah, well, clicker is important. For instance, in tic-tac-toe, the strategy to victory is fairly straightforward. There are not everybody learns how to win in tic-tac-toe, and when you win, you can really tell, I won. If you've seen the animated film Nimona, the main character Nimona has a somewhat fuzzy strategy, but a clear definition of success. So her plan is we do something, 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 and then we win. When it comes to cloud, what is this something, something? What is the victory? What is cloud success? How can we tell? And before I jump into description, this service, that service, that service, I think it's more important to discuss what is actually cloud. What are good things to do in the cloud? And then we can switch. But before we go to fundamental questions about what is cloud and whatnot, Jan has one thing that he wants to take out from this talk. Mine, one thing is there is no one single thing or activity that you can do in the cloud and be successful. It's a complex of things. You see, doing cloud successfully is in a way similar to surfing. You don't surf in order to get to the shore as quickly as possible. You surf in order to stay on the wave for as long as possible. And the more I try to stay on the edge of this wave, the more I ask, so what is actually cloud? And as usual, we start with Wikipedia, good starting point. And Wikipedia gives a rather dry definition, which essentially is cloud is compute, networking, storage, identity management, all of that driven by APIs. Yes, this kind of describes it, but it's similar to saying that an elephant is an object. Yes, that is a correct statement, but elephant is a little bit more than just an object. It doesn't describe what an elephant is. And to make things more complicated, there is the AWS Outpost, a service that allows you to run EC2 API on your own hardware in a data center. Is that cloud? Is that on demand, or that's confusing? So, but we also have this perspective. AWS has over 200 services. If I were to spend 5 seconds naming each service that is out there, I will be done in 20 minutes and the talk will be over. That's a lot of services. That is a lot of on-demand resources. And the question is, how do we make sense out of this? Which service is the right one? Which is the one true service? Well, spoiler alert, there is no one true service. Each and every one of them has their purpose. So when people say it depends, because that is. It really depends on the use case, on the situation, on the time, and et cetera, et cetera. And I would say that probably cloud is exactly this wide variety of choices. But, well, it's a little bit hard to pinpoint what the cloud is. And because of this wide variety of choices, doing cloud is actually quite easy. And doing amazing things is easy. Today, in a couple of minutes, you can provision a workload that will span multiple geographic locations, will be highly available, will be resilient, will be super performant, something that 10 years ago would be quite hard to achieve and rare. Today it's, well, click, 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 and you have it. So doing cloud is easy. I think the hard thing about cloud is doing cloud right. Well, looks like the definition of cloud is a little bit confusing. Maybe it's the wrong approach. Maybe we should not be asking what is the cloud. Maybe we should be trying to find out from the good things to do in the cloud. And I mentioned before that I believe there is no one single activity that you can do in the cloud and be successful. But what if there is one? In math and logic, in math and formal logic, there is this method of proving your point, reductio ad absurdum, where you suppose something opposite of what you want to prove and show that that doesn't make sense. For instance, we all know that a government printing money just like this is a bad idea. But we can assume, let's assume that it's a good idea. They have budget problems. The government starts printing money. What it leads to? Money loses value. Problem actually becomes even more complicated. Thus, governments should not just print money. So let's assume that there is one single thing that you can do in the cloud and be successful. And we start with the big guns. Before I go to the well-architected framework, let's have a show of hands. Who in the audience knows about well-architected framework? Please raise your hand. Okay. Keep your hand if you use it regularly. Well, well-architected framework is an excellent set of question tools, principles that allows you to analyze your plan and your workload for being right one. Not exactly right one, but being efficient, being cost efficient, computationally efficient, ecologically efficient, resilient, etc., etc. Normally people do this, the well-architected reviews just before going to production, which in my opinion is a little late, because if you discover something that is missing, like, okay, tomorrow we're going to production, what should we do? It is suggested to repeat well-architected reviews for your workloads every 2 years or so, give or take. And while in itself well-architected is an excellent tool, it doesn't prescribe which services and patterns to choose. Just how to analyze, how to look, and which areas to look at. So it's theoretically possible to have a wrong workload pass well-architected framework. Furthermore, at Helvetia, we're using well-architected pillars to structure the design documents for our services. I think it's very useful. We start exactly so when we start a new solution or refactoring an existing one, we know what will be asked when the well-architected review will happen, so which areas to address. Well-architected framework is essential. You should do this, but it's kind of not enough. It doesn't solve all of your problems. So maybe it's not well-architected review framework, maybe it's FinOps. FinOps stands for Financial Operations, and it's where cloud cost transparency really shines. The idea with FinOps is to assign cost ownership and responsibility to the parts of the organization which actually care about those parts. So not somebody's running infrastructure and they incur costs, and somebody using that infrastructure says, oh, well, not my problem, make it cheaper. So FinOps shifts this. It's hard work, it's very difficult, it takes organizational changes, but it brings really, really good benefits. And thanks to FinOps, you can shift questions like, should we do this? Should we use this architecture or that approach? You can shift this into, if we choose this approach, the cost will be this. If we choose that approach, the cost will be other. This is the language business stakeholders love and understand. This is how you talk to people who actually pay. This is the cost. Do you want it? Should we do this? FinOps is another absolute must that you should have as part of your cloud success. But again, it's not enough. What if, for instance, by shifting your workload from EC2 instances to serverless, you will have massive savings, which is actually a plausible scenario. It's not always like this, but it's possible. FinOps is not responsible for the architecture. So FinOps is great, you should be doing this, but it's also not enough. Architecture, indeed. Maybe there is one true architecture. Some companies manage servers, some run Kubernetes, and serverless on them. Cloud is indeed about choosing the right architecture, right tool for your company at the particular time. And what works for one company is not necessarily good for the other company. It really depends on the team, on the skills, on the willingness to work, on the time of year, on your company, what you're doing. So many factors, and that's why there are so many choices in the cloud. And all of them are right for some particular use cases, but none of them is right for all of them, unfortunately. So, for example, at Helvetia, we're using two different container offerings from Amazon. AWS Rosa, which is a managed OpenShift Kubernetes platform, and we use Elastic Container Service. Neither of them is wrong. They both bring value to the use case they are applied to. So, not exactly architecture. Maybe it's the automation and infrastructure as code. Well, behavioral science concluded that interesting thing about us humans do not scale. An ideal team of humans is 3 people. Make it more than 7, and it's very hard to organize, coordinate. Humans are great for creative problem solving. We're not good at doing manual things at scale. It's our human nature. And because of this, doing anything non-trivial and sustainable in the cloud cannot be manual. This is where automation comes into play. This is where infrastructure as code and GitOps, hopefully you're all doing all of that, come into play. The idea there is to have a clear computer-readable definition of the infrastructure that you want to have in the cloud, and let the robots make sure that actually this is happening. It's great, seriously. And thanks to extensive automation, Helvetia's AWS team is not more than 5 people, depending how you count. And at that, we're managing more than 200 accounts. All thanks to automation. But furthermore, don't automate, obliterate. This was declared somewhere in 1990s. The principle is that the best work you can do is the work you don't do. It's the easiest work. So instead of doing something, if you cannot do that, this is the best option. An example is you can implement EC2 patching processes, tools, etc. As an alternative, you can move to serverless of some sort and not patch at all. It's much easier not patching than patching. Obliterate. So automation is great. You should be doing automation if you're taking this thing seriously. But automation alone also, unfortunately, is not enough. Well, last but not least, maybe the good governance is all you need. Governance is all about knowledge. There are roughly 4 knowledges there. Observability is the knowledge of what you have. Monitoring is knowledge that what you have actually works the way it should be doing. Security is the knowledge of what you need to fix and how soon. And change management is knowledge of the impact of the changes you perform to the platform, so that you don't get surprised, so that you don't make changes in production for the first time and, oh my God, something broke. These four don't make exciting breaking news like new JavaScript frameworks used to be, at least in some recent past. But when these four are not followed, we get breaking news about planet-wide outages. You probably heard about those. Important? Yes. The only important, unfortunately, no. These four allow you to crash less, but they don't allow you to move at the speed you should be moving. They just like a safety brakes, but still not enough. And with this, I conclude that indeed there is no single thing that is sufficient to do in the cloud. One of the working titles of this talk was Multidimensional Chess of Cloud Success. The examples I used correspond to the pillars of well-architected framework. But instead of doing a review just once in a while, this is, in my opinion, cloud success is applying the pillars, the knowledge from the well-architected framework on a continuous basis across the platform, across the workloads. So, in essence, cloud success is all about modernization, application of well-architected framework, FinOps, automation, infrastructure as code, GitOps, modern change management, solid identity management, observability, and security. Well, so much for something, we win. And with cloud success somewhat clarified, and the cloud as well, what you see here is the architecture of our landing zone. It's pretty typical. It really resembles what Control Tower is producing. We didn't use Control Tower simply because it was not available at the time. But essentially, it's the same principle, and we're following exactly that. It's quite common to split your workloads and environments into multiple accounts. So have one account for production, one account for development, test, etc., etc., etc. This is how we ended up with 200 accounts plus. And this is why the automation is absolutely crucial. You cannot make platform changes in 200 accounts. It's simply impossible. This is why we strive to automate as much as we can. The account creation, account vending is also automated. Remember the definition of cloud: storage, compute, networking, identity management. Identity management, one identity across the entire platform, is also absolutely crucial. That's why we automated AWS single sign-on. As usual, we centralized CloudTrail. For security reasons, we're building an observability platform using AWS Config, AWS Resource Explorer, and Systems Manager, so that we know what is actually out there. Does it correspond to what we want? And this information, this whole setup, gives us control of the platform. Gives us control and knowledge that what we do allows our users to iterate on their solutions real quick, at the speed that they want to. When people have to submit a ticket and wait for a day or a week for a server to be created, this is a true productivity killer. So self-service is absolutely essential for cloud success. Well, as Jan mentioned, in addition to platform, we did the data center exit. One popular mistake with cloud migrations is a gradual migration together with the modernization. Sometimes it works, sometimes it's okay, but especially for bigger companies, what happens is companies start migrating, move some workloads to the cloud, realize that modernizing and moving is taking time, it's difficult. They end up with migration half completed. They are still on premises, they are in a cloud, they have to manage two different platforms essentially, and this is where some companies even decide, okay, it's not worth it, let's go back to premises. Cloud is too complicated. Well, in just 2 years, thanks to our partners, AWS, NordCloud, and Swisscom, over 200 applications were migrated lift and shift. Plain, simple. And even after those 2 years, we have several edge cases which are, well, still work in progress. But what matters is that we're in the cloud now. And now that we're in the cloud, we can really use its potential. Here is an example of an application that was a single server with an attached volume to it, slow, fragile, not scaling. We took that, we modernized it, we refactored this into a modern architecture. The server went to serverless servers in Elastic Container Servers using Fargate. The database of that application went to RDS. The attached volume, which was reaching the limits of EBS capacity, moved to Elastic File System. We're able to use S3 for cold storage of files that are not so used. So really took the application, which was very fragile and not well performing, and moved it to use native good cloud capabilities. The architecture became more complex. Interesting thing is that total cost of ownership of running this thing remained virtually the same. The reason for that is that this architecture doesn't take any maintenance at all. It self-heals, it self-scales. The updates are easy and automated, so we don't have to do anything. Virtually don't have to do anything about. It just works. That's it. So, and when problems happen, well, it self-heals. It's really great to be able to do this thanks to the cloud capabilities, various cloud capabilities. And as in the previous example, cloud has many ways to implement solutions. Another popular mistake, as Jan mentioned, the one takeaway, is to stop after lift and shift. Companies that do that very soon discover that they end up with a very expensive data center in the cloud. But the problem is that they're not really using the cloud. It's just an expensive, very expensive data center in the cloud. So Jan mentioned the 7 migration strategies, the 7 R's. The thing about them is that 4 of them are best applied in the, already when in the cloud. First is retire. It's available. Retire is when you decommission a solution. It's available in data center. You can do that definitely. But when you get next month's bill for your cloud resources and you see that cost went down, this is where you see, oh yeah, that was a very good retirement. Repurchase is when you change a workload from old something to the same but cloud friendly. At Helvetia, we follow the top-down approach. So when we repurchase something, we start with SaaS solutions. So there was some server running on premises, but we found the same company providing the same as a SaaS. If there is no SaaS, then we go for PaaS, serverless, and everything else. Replatform is when you make small changes to the application without changing the architecture. So for instance, moving database from EC2 to RDS. And finally, refactor, my favorite, is what was the previous example, where you really used native cloud capabilities to utilize cloud to its full extent. It's the most work, but also the most reward. Another example from our practice. We have another application which is quite costly in licensing costs. It's not insurance specific, so it's kind of an easy candidate, costly and not insurance specific. What we did is a mental experiment. We tried to design what would it be, how would we implement this very solution, but using modern cloud technologies. We designed a thing, we did the cost estimate and discovered that we can cut 90% of the cost. And it's a really expensive solution. Does it mean that we start immediately implementing it with the cloud? Not necessarily, but this gives us 2 data points, 2 questions. One is question to the business. We can cut costs of this particular application by 90%. Would you like us to do it? The catch is that we need to put some work to actually implement this thing. So there will be some upfront investment. And the second question is to the vendor. Guys, we're paying you a lot of money. We know we can pay much less. would you like to negotiate? And final piece is the modern change management. Change management, the purpose of change management is basically to make sure that there are fewer risks when you make changes. Traditionally, this would mean change plans, change windows, doing changes in off hours, so people staying late at night, and quite often making changes first time in production and getting surprises, oh my god, this was such a bad idea and everything is broken. What we do instead is we use automation, infrastructure as code. We deploy the changes first in the test environment so we know what will actually happen when we go to production. This allows us to move fast. And thanks to GitOps, feature flags, we can actually deploy changes in small chunks and revert changes if we see that something is not working as expected. Well, it's not perfect, but it's kind of the point. Cloud success is not a state, it's an ongoing journey. And now that we're in the cloud, we further develop the platform, modernize, and implement using new abilities, extend the governance, rinse, repeat. In a way, indeed, this is application of the pillars of well-architected framework. Not exactly as trivial as tic-tac-toe, but much more interesting. Thank you for your attention, and Jan wants to add something.
There's one last thing before the drinks, and this is AWS is a data-driven company, so we really love to get your feedback. So open the app. If you haven't downloaded, there is a QR code on the back of your badge, and provide a rating for our session. You maybe need to hit the filter that show previous sessions. Thank you so much for attention, and now it's time for drink. See you next year.